Good morning, students. Welcome back to science class. Today we shall start new chapter, that is sound. Okay. In the previous year we had studied about sound chapter. Okay. See, every day we hear sounds from different sources like birds, vehicles, machines, fans, etc. We will use different kinds of sounds. Okay. In the previous year we had studied sound is a form of energy. Okay, even sound can do a work, so that's why we call sound is a form of energy. Okay, and also we had studied we can convert sound energy into other forms of energy and other forms into sound energy. For example, if you take a mic, okay, if you speak in front of the mic, so then see, you'll produce a sound, means see, we'll convert that sound energy into light energy. Then that sound, see, then that mic is connected to speaker. Okay, so then that speaker once again which converts electrical energy into sound energy. First that mic which converts sound energy into electrical energy, then that speaker which converts electrical energy into sound energy. So this is one example. So we can convert the sound energy into other forms and other forms into sound energy. Okay. So in this chapter we are going to study about how we can produce a sound and how it travels in the medium and the ranges. Okay, the ranges. Then the uses of sounds and the uses of ultrasonic sounds. Okay. So now first we will discuss how we can produce a sound. Okay, so already you know how we can, in the previous year we have studied how we can produce a sound. Just do like this. Okay, then you can't produce sound. Suppose, say, this is a marker. Okay, so now if you hold like this, do you hear any kind of sound? No, correct. But when you set this marker into vibration like this, so then you can hear sound. Okay, so here see that one activity is there in a textbook, that is vibrating tuning fork. Okay, so just read that activity. If you want to produce a sound, then the vibrations are necessary. The sound is created, that is due to the vibrations. Okay, so now we are humans. Okay, how we can produce sound? See, actually here in our neck there are two vocal cords are there. Okay, so we will push. See, when you want to talk, when you wish to talk, then we will push the air through, there is one pipe is there. Okay, so while pushing that air, what happens, those vocal cords, they will vibrate, so then we can produce a sound. Okay, now if you take a guitar, right, guitar, how it produces sound. Okay, just when this is a guitar. Yes, just imagine this is a guitar. Okay, so here on these are strings. Okay, how we can produce sound in a guitar. See, when you vibrate these strings, okay, so then sound is produces. Okay, then what about, if you take a speaker? Okay, so there also, when that see, yes, now take a speaker. Okay, that's you have seen this kind of in speaker. Okay, so when this what we call drum, it is just like a drum. Okay, so when this vibrates, then we can produce a sound. Clear? So how birds can make a sound. While they are jumping, while they are flying, you can hear the sound. Correct? Because they will set the wings into vibrations. Okay, so then we can hear the sound. So we can produce a sound, that is because of vibrations only. Okay, when the objects are in motion, when the objects are set into motion, then the sound is produces. Otherwise there is no vibration, then there is no sound. Okay, so we can produce sound, that is because of vibrations only. Okay, so when the objects are in vibration, then they produce a sound. Okay, next move to propagation of sound. Okay, so this is very very important. You know, for example, say she's saying A and a one more person B. Okay, so now this person he will speak. Okay, he will say something. Then this person he can hear his voice. Okay, so he is singing the song. So he will listen that song. Actually, see here, this person he produced a sound. Okay, so he can hear. Correct. How that sound is traveled from this position to this position, from his mouth to his ear. Actually, he produces sound. Okay, so he can hear that sound. Clear? When he will produce that sound, at that time he can hear the sound. Clear? But how that sound is traveled from this position A to this position, say this position to this position. Okay? For example, I am speaking here. You can hear my voice. You are sitting in your home. How it is possible? Clear? Now we will discuss. Okay, see here, the arrangement of atoms. Okay, in solid all the atoms are tightly arranged. In water, loosely arranged. But what about in air? In air, atoms are freely arranged. Okay, see, all the atoms are arranged like this. Yes. Here, just imagine these are atoms. Okay, these are atoms. In air, okay, this is a air. Okay, in air, all the atoms are freely arranged. Okay, so here, when you produce a sound, what will happen? Now, these atoms they will receive that sound energy. Okay, that sound energy which falls on these atoms. Clear? So then these atoms they will collide with the neighboring atoms. Why? Because they have gained energy from they have gained some energy. So that energy is sound energy. Okay. So then they will collide with the neighboring atoms. So when you produce a sound here, what will happen? These atoms they will receive energy, they will gain this energy, then they will collide with the neighboring atom. Okay. See here, they will collide with like this. They will collide like this. Okay, see, I'm just taking example just a few atoms. When you produce a sound, the millions of atoms they will collide with the neighboring atoms. Okay, so now they will collide with the neighboring atoms. Now, see here, they will collide with the neighboring atoms, right? So now, see, actually, initially, in these atom, for example, this one. So this atom, see, it gained energy. Okay, then when it collides with neighboring atoms, at that time, this atom it loses energy to this atom. Okay, so then it will come back to its original position. So once again, it will come back to its original position. So now, after collision, this atom it will gain energy. Okay, so then it will move forward. Then it will collide with neighboring atom. Neighboring atom. Clear? So once again, what will happen after collision? This atom it gains energy and it loses energy. So then once again it will come back to its its position. Okay? Yes. Now this atom gain energy. So once again it will collide with the neighboring atom. Neighboring atom. So once again it loses and it will come back to its original position. Then it will move forward. Then it will collide with the neighboring atoms. Okay? So just here, let's observe over there. Okay. Yes. Up to here we will collect, and that sound it will enter into his eyes. Okay. So like this, sound energy it will move. Sound travels. Okay. For example, here. So I am talking here. You are in your house. So right now you are listening my voice. Okay. See here near my mouth. Here so many atoms are present. Okay. They will see when I talk. What will happen? The atoms, those which are present near my mouth, they will gain energy and they will collide with neighboring atom. Then it catches that mic. Okay, so later that mic is that sound converted into electrical. That is later. Okay, suppose here this person A and person B are. Okay, so here person B can listen his voice. Okay, so when he produces sound, what will happen? The atoms, those are present near this person A, they will gain energy and they will collide with neighboring atoms. Okay, so like this, the sound energy travels. Okay, so here, in other words, we can explain. See, now take this one. So here all the atoms join. Okay. So when you produce a sound, they will collide like this. Okay. So after collision, the collide those after collision, the atoms they come back to their original positions like this. Okay. So this is the during collision, right? And this is before collision, after collision. Okay. See here, when you produce a sound, the atoms they will collide with neighboring atoms. Clear? And these are after collision, they will come back to their original position. Okay. Then okay, see here. So now here, see this one and this one represents. We call what is that? What is that? Compressions, and this one is called rarefactions. Okay. Why? Because here when you produce a sound, what will happen? The atoms they will collide with the this collision we call compressions. Okay, compressions. So after collision, so these net collide with the neighboring atom. So once again they will come to their original position, right? So we call this is rarefactions. Okay, see here. So person A and here person B. So when he produces sound, so he can hear. Okay, so that sound energy it will travel from this position to this position. Okay, so when traveling that sound from here to here, so this kind of millions of compressions and rarefactions takes place. So like this, the sound will travel from one point to another point, from the producer to observer. Sorry, listener. Okay, so here when he produces sound, okay, when he makes that sound, okay, so this kind of compressions and rarefactions continuously takes place, and finally that sound energy, that sound energy is received by that person B. Okay, so here also means same. What when you produce sound, the atoms they will collide with neighboring atoms. After collision, they will come back to its original position. Okay, so that compression, okay, that collision when you produce a sound, the atoms collide, right? Collide with the neighboring atoms. So that collision is called compressions. So after collision, what will happen? The atoms, okay, those collide with the neighboring atoms. They lose the energy. They will come back to their original positions. Okay, the atoms, those gained energy from the during collision, they will move forward. Okay, so this is called rarefactions. So clear? Okay, so if you hear any sound, okay, so that sound is fall on your here, while coming from that from where that person produces sound, from that person to your here. So these kind of compressions and rarefactions takes place. So clear? So this is about propagation of sound. Propagation means how that sound travels. Okay, so like this sound travels. Okay, yes. So next to move to sound needs a medium. Sound needs a medium. Sound needs a medium. Here one experiment is there, that is a bell jar experiment. See here, this is a bell jar experiment. So here you have to keep one bell, okay, that alarm bell, okay. Then initially just you have to set that alarm, okay. So just you have to cover it and you have to connect this bell to electric connection, okay. So when you set the alarm, what will happen? It produces sound, so then you can hear. Okay. Next, you have to suck the air from this jar. Okay, you have to suck that complete air from this jar. Then you have to suck that alarm. So at that time, you can't hear any kind of sound. Okay, so initially before sucking the air from the jar, you can hear the sound. Clear? But when you suck the complete air from this jar through this vacuum pump, so after when you set the alarm, then you can't hear any kind of sound. Okay, so what it indicates, earlier we had studied the propagation of sound, how that sound it will travel, okay, from one place to another place. Clear? Means where that sound in production, that production point to that where we can hear that sound, okay, from Production to hearing that one. So you have studied how that sound will travel. Okay. So now here what it indicates, when you suck the air from the bell jar, then you can't hear any kind of sound. Okay. See here this experiment which shows. Okay. From this experiment we can say that, so to travel sound, okay, it needs medium. It needs medium. Okay. So to travel that sound, so that's why sound it needs a medium to travel. Okay. If you that sound, if it wants to travel from one point to another point, then it requires a medium, or then it needs a medium. If there is no medium, then there is no sound, then there is no propagation of sound. So then what is medium? For example, take a solid. In solid all the atoms are tightly arranged, right? So then we can, then solid is one medium. Then take air. In air all the atoms are freely arranged. Okay, all the atoms are freely arranged. Then we can say that that is also air medium. That is also one medium. Which medium? That is air medium. This is a solid medium, air medium. Then if you take water, in water, atoms are freely arranged. Freely arranged. Then we can call that, even that water is also what medium. That is water medium. Then if you take a diesel, in the diesel also the arrangement of particles are different. Okay, even the diesel is also liquid, but the arrangement of particles in water and diesel, that is different, right? So that's why we call even that diesel is also another medium. Clear? So clear? So medium means solid. We call that solid medium, air medium, water medium, like that. Okay. So now when you remove the air, which means what? So now this jar, it will become a vacuum. Okay, it will become vacuum. Vacuum means what? It's an empty space. Means there are no electrons. Suppose if you want to create this room as a vacuum, you have to remove that, or we have to remove the air from this room. Okay, there is no medium, right? Because to travel sound it requires some atoms. If you create this room as a vacuum, then there are no atoms. Okay, if atoms are not there in one place, then we call that place as vacuum. So clear? See, even in vacuum you can't breathe. Okay, so that is important thing. Okay, you should know that one. So clear, right? So sound. Okay, what indicates this experiment? This experiment indicates a sound. It requires a medium. Okay, it requires medium, or it needs medium to travel. Okay, medium is what? It requires atoms. Okay, that sound energy, it will travel from one point to another point. That is through atoms only. Okay, already you have studied, right? So when you produce a sound here, what will happen? The neighboring atoms, they will receive energy. Okay, then they will collide with neighboring atoms. After collision, they will come back. Then these atoms, they will collide with neighboring. After that, they will come back. And but what these atoms, once again, they will collide with the neighboring atoms. So that is compressions and rarefactions. Okay, so but here in this bell jar experiment, when you remove or when you suck that air, what will happen? This jar, it will become a vacuum, which means there are no atoms. So that's why when you produce a sound here, okay, to travel that sound, it requires medium, means it requires atoms, right? Here there are no atoms. Okay, so that's why you can't hear any kind of sound. Okay, so keep in your mind, if you produce, or if you create a sound, or if you produce a sound in a vacuum, then you can't hear anything. Why? Because there are no atoms. Okay, so sound, it requires, or it needs a medium to travel. So clear? Yes, next move to sound waves are longitudinal waves. Okay, sound waves are longitudinal waves. See, actually, in waves there are two types. One is a transverse waves, and another one is longitudinal waves. Okay, but sound waves are longitudinal waves. Let's see why we do.